settlekan chapter. Alright, so teruskan untuk chapter 6. Belum tu ada masalah ke sekarang ni, musim banjir ni? Nak akses internet ke? Ada yang duduk di Terengganu ke Kelantan ke Pahang kan? Johor pun teruk juga banjir. Semua okey?
So far okey, Doktor.
Okey.
Alright, kalau ada masalah nanti bagi tahu lah. Alright, so kita boleh membantu untuk settlekan masalah apa yang ada. Okay, so saya present untuk chapter. So kalau ada siapa kawan-kawan yang nak masuk kelas tu bagi tahu lah, kadang-kadang saya tak perasan kawan-kawan you nak masuk tu. So saya teruskan dengan chapter 6 ni. Okey, semua boleh nampak slide saya chapter 6?
Boleh, Doktor.
Boleh.
Good. So saya teruskan lah. So chapter 6, two-port network. So basically, what is the two-port network? In this chapter, we will cover on the introduction of two-port network, impedance and admittance matrix of linear two-port, the hybrid parameter, and the transmission parameter or transmission matrices. So the learning objective, study the basic type of two-port model. We have admittance parameter, we have impedance parameter, hybrid and transmission parameter. So next we need to understand how to convert from one model into another. So just go first on the introduction. So the two reasons why to study two-port network. First, such network are useful in communication, control system, power system, and electronic. By knowing the parameter of two-port network, you are able to treat it as a black box when embedded with a larger network. So if you can see the linear network, we have A, B, C point. In many situations, one is not interested in the internal organization of network. So we doesn't want to know what inside the box, basically what inside the linear network. So but we need to know what is the current, what is the voltage applied to the network. So in order to model the network, we will cover with the two-port theorem. So that's why a description relating into input and output variable may be sufficient to know what inside the network, basically. So if we go to this system, block diagram of an audio amplifier system, we have, for example, we have microphone, we have preamplifier, tone and volume control amplifier, and the last one is loudspeaker. So basically, the microphone is the one we call as a one port because it's only one input. But for preamplifier, we will say it as a two port, and then at the end, speaker is one port. So what is the difference between one port and two port? So basically, if you have a two port, basically you will have two separate ports for input and output. That's why we call it as a two port network. One port is an access to a network and consists of two terminals. So in one port network, we can see here we have current go through the system and the output is I1 also. So this is the one port model. But for two port model, you can see here we have input go inside, and then we have another output I1, and then at the output port they got I2, and then the output of the I2 is we call it the same is I2. So we have two port network, we have one port network. So this chapter 6 we will cover on two-port network. Right. So basically, this is the description of one-port network. This is one pair of terminal. If we have two pair of terminal, we call it as a two-port. So current entering a port is equals to current leaving a port. So you can see I1 go in, output is also I1. For the output port, I2 go in, the output for the port is I2. So basically we have V1, V2 is so current that represent for each port, V1 that and I1 represent input port. Basically V2 and related to output port.
Excuse me, ada orang yang masuk.
Okay, thank you. All right, so we continue on. So we will cover on 4 parameter. We have impedance Z parameter. We call it as a Z parameter because inside this the equation and the formula we have Z. All this we can say Z11, Z12, Z21, Z22. So these all parameter that you need to determine from the circuit. So we have at Y11, Y12, and Y22. This is equation that relation on the admittance Y parameter. Then we have hybrid parameter H represent hybrid parameter H11, H12, H21, H22. This is the equation that related to hybrid parameter, and this is transmission parameter A, B, C, D. So all these parameter you need to determine from the circuit. But it's basically you need the question will ask you whether to find impedance, admittance, hybrid or transmission parameter. From the question you come out with this parameter. Okay. So first we cover on Z parameter. So Z parameter also called as impedance because we have Z, the impedance, and the unit is ohm. So impedance parameter is commonly used in the synthesis of filters and also useful in the design and analysis of impedance and power distribution network. So the two-port network may be voltage or driven current, right? So if we see this two-port network, basically the driven we call as this port network driven by the voltage source because we apply voltage V1, V2 at the input and output port. For this number 2 figure, we can see this is current. The two-port network driven by current source because it's apply current source at input and current source at the output. All right. So for the two-port network, basically you need to represent all this with V1, I1 for the left-hand side. For the right-hand side, we represent as a V2, I2 for the output port, right? So this is the sign that V1 will be positive and negative, V2 also positive and negative. So this is standard sign before we go through the analysis of two-port network. So if we represent the black spot with the Z parameter is like this, right? So we have two-port network, we have Z11, Z12, Z21, Z22. So if we go to the equation that represent all the Z parameter, we call as V1 equals to Z11 I1 plus Z12 I2. So V2 equals to Z21 I1, Z22 I2. So this equation to remember, right? Because if you have got a wrong formula, wrong equation, you will be a wrong analysis when you try to answer the question. So you remember all this formula for Z parameter. V1 equals to Z11 I1 plus Z12 I2. V2 represent here Z21 I1 plus Z22 I2. So basically this is the for Z parameter, and then if we go into the metric form, we represent it as V1, V2 equals to, in this metric form, Z11, Z12, Z21, Z22, I1 and I2. If you times the Z11, I1 plus Z, if you times this metric, basically it will go through this equation, right? It's the same thing here. Ada nak masuk ke? Okay.
Okay, Doktor.
Okay, alright, good. So how to determine Z11, Z12, Z21, Z22? So we need to set it I1 or I2 equals to 0, right? If you can see here, if you set I2 equals to 0, you set I2 to the 0, according to this equation, when I2 equals to 0, you can get Z11 and Z21, because if you go put a 0 to I2 here, I2, you can get this formula will be reduced to Z11 equals to V1 over I1, Z21 equals to over I1. So, and then next, if you apply I1 equals to 0, from this equation, if you set I1 equals to 0, what you can get here is Z12 equals to V1 over I2, Z22 equals to V2 over I2. So you need to determine all parameter according to this formula, right? So how to set this I1 and I2 become 0? So in Z parameter, what you need to do, you need to do two tests, which mean first you need to open circuit at port number 2, and then second test you can determine all these parameter by open circuit at port number 1. So if you can see here, if you open circuit at port number 2, mean I2 equals to 0, you can get Z11 and Z21. If you set the open circuit at port number 1, so you set I1 equals to 0, you can get Z12 and Z22. So this is a description now. What is the Z11? What is Z12, Z21 and Z22?
Doktor,
Here?
sorry Doktor tak record ke kelas ni?
Saya tak record sebab ni komputer baru saya dapat. So, boleh siapa-siapa kalau nak record kan?
Alright.
Okay.
Doktor, ada orang dah masuk. Saya ada record.
Okay, bagus. Good, good. Okay. Siapa yang record tu nanti share, alright? Alright, next step is how to do the test. The test is mean that you need to open circuit at port number 1 and then open circuit at port number 2. This is the first task you need to do. When you have a question, you need to determine the Z parameter, for example. So in order to parameter, you need to perform two tests. Test number 1, you set I2 is a 0. So means that this circuit port number 2, you just open circuit at port number 2, but port number 1, you just apply voltage, right? So when this happen here, this means that your output of 2 is 0. So when this is setting to 0, you can determine Z11 and Z21. This equation you set I2 equals to 0. So the V1 equals to Z11 I1. You need to determine Z parameter, right? So Z equals to V over I. Same thing here, determine Z21 equals to V2 over I1. So you don't have to know what is the value for V1, I1, V2, I2 because this inside this circuit you have a resistance or impedance. From the ratio of V1 over I1, you can determine the impedance value. We will see from the after this. So input port, apply voltage source. So this is a test number 1. You open port, open output port, or set I2 equals to 0. Next. So basically next you need to do second test. Second test means that you input port to I1 equals to 0. After that you apply voltage source to the circuit. So in this figure, suppose this one is open, right? So I need to change here, means that suppose this one is set to be 0. Should fill. All right, so you need to set like this. So it means that your input so you leave this become 0, you can get Z12 and Z22 into this equation. This is a standard equation for Z parameter. When you set I1 equals to 0, V1 equals to Z12 I2, V2 equals to Z22 I2, then find the ratio between V1 and you can get Z12. Determine the ratio between V2 I2, you can get Z22. So at the end, you can get 4 parameters for Z. Z11, Z12, Z21, Z22. So complete your task. The task is to find the impedance parameter, or we call as a Z parameter. The unit will be ohm, right? All right, so after you got the Z parameter, basically you can draw the equivalent circuit for Z parameter. So this is the equivalent circuit for Z parameter. If you can see here, we have Z11, we have a voltage dependent source, I2, Z12, I2, and then on the right side, we have Z22, I1, Z21, right? So this is the equivalent circuit for Z parameter. After you get Z parameter, basically you can come out with this equivalent circuit for Z parameter. So this is a name for the Z parameter, right? So we call Z11 as a input impedance, Z12 open circuit transfer impedance from port 1 to port 2. So basically you don't have to remember this name, but you need to understand how from the Z11, Z21, and Z12, Z22, from there you need to convert to equivalent circuit that represent this Z parameter model. Okay. If the Z parameter is reciprocal, so you can represent the equivalent with the more simple model like this, right? If the Z parameter is reciprocal, right? So you can represent the model for Z parameter become a simple model like this. We have this is the impedance for Z11 minus Z12, right? Because of 4 parameter of Z, if you Z11 minus Z12, you get one value. So this is value for Z11 minus Z12. Another parameter here, we call Z22 minus Z12. You do the minus here, then you got another value. So this is a represent value for this part. And then what is the value part is Z12. So this is the equivalent model if the Z parameter is reciprocal. So what is mean by reciprocal? Inside the there is no dependent sources, and then another point here, voltage source and ideal emitter connected to the port intangible. So Z11 equals to Z2. So mean that if if you replace emitter here, you get current. Then you replace emitter at this port number 1, the current will be same. So is the reciprocal means Z12 equals to Z21. According to your Z parameter, you got 4 Z11, Z12, Z21, Z22. Then you compare Z11 equals or not with Z21. If equal means the network is reciprocal. So you can represent your model with this equivalent circuit. Right. Okay. Any question until this?
So far, okay, doktor.
Boleh kan? Nanti kita tengok dia punya lagi clear. So another point here, if this is symmetry or not. So if there is symmetry, it means that your Z11 must be equal to Z22, right? So you first reciprocal, Z11, Z12 equals to Z21, for 3, Z11 equals to Z22. That is a symmetrical. So this is another characteristic of a two-port network, right? So ZA. So if the symmetrical means that A here will be same as a Z here. The parameter is same. For example, is 5 ohm here. This is really 5 ohm. For example, here is symmetrical for pi parameter, for pi circuit. So this one we call as a T circuit. This one like pi circuit. So here is ZD is the same ZD here. So we have another parameter ZC, for example. So this ZD is the same. So we call it as a symmetrical. Or the easiest way, you compare Z11 equals or not with Z22. If equal, this is symmetrical, right? For example, here we have circuit. Determine Z parameter for the circuit, right? So it means that you need to find the question asks you to determine Z parameter. So they only give you this type of circuit. From this circuit, you need to determine Z parameter. So bear in your mind that Z parameter or we have Y, H or A parameter. Basically, you need to determine 4 parameter in metric form right here. So this is answer for this question, right? So how to solve this question? Basically, you need to do 2 tests. We have open test port number 2, and then after that you open test at port number 1. Means that you set I1 or I2 become 0. Right, from there you can get the Z parameter. Oh, ini tak ada solution Alright, tak apa. Saya pergi satu lagi, saya rasa saya dah save solution je kat sini. Oh, saya salah masuk sini Okay, so right, kita pergi kat sini. So this is solution for this circuit. We have 20 ohm, 30 ohm, 40 ohm to determine Z parameter. So first, you need to set output port will be 0. I2 equals to 0. So means that here you apply, you open circuit at port number 2, then you apply voltage at port number 1, right? So the Z parameter Z11 equals to V1 over I1. So how they got this equation basically is from the general equation for Z parameter. We have Z11. So we have this equation, right? So V1 equals to Z11 I1. And then we have V2 equals to Z22 I2, right? Plus Z22 I1. So from this equation, basically, you can get this one, Z11. Right, so first you say I2 equals to 0, you need to find the ratio between V1 I1. So this ratio, basically, you don't have to know what is the voltage or what is the current I1, V1. What you need to do is you need to do a ratio only. So according to this ratio, V1 over I1. So what is the V1? V1 is, this is your V1, and then this part is your V2, right? So then this is I1, and then go to this circuit is I2. So the point here, basically, you need to determine the ratio between V1 and I1. So how to determine V1 over I1? So V1 voltage 1, if you do so when the I2 equals to 0, so there is no current across 330 ohms. So V1 equals to I1 20. You do Kirchhoff voltage law. So V1 equals to 20 I1 plus 40 I1. So the same I1 here we get. So next, from equation there, you divide by I1. So you can get here, because V1 divide by I1. So this is the top, so your V1 over I1, you can get 60 ohm, because this I1, it will be cancelled out. For Z21, you need to find ratio between V2 and I1. So where is your V2? V2 is this part, right? So the V2, the current is not go through 30 ohm. So V2 basically is a voltage across 40 ohm, right? So how to get voltage across 40 ohm? I1 will be time 40. So we can V2 divided by I1, you can get 40 ohm. So the same at second test, you need to set I1 equals to 0. So it means that this port, I1, you remove the voltage source. From here, you apply voltage source at port number 2. So the current I1 will be 0. So next, determine Z12. Z12 is the ratio between V1 over I2. So where is your V1? Although you open circuit at port number 1, only current will be 0. But your V1 is still there, because V1 will refer to this branch. So V1 refer to this 40 ohm voltage across, equals to 40 times I2, because the current from I2 will go flow to 30 ohm and 40 ohm, go back to the V2 source. So when you do the ratio between V1 I2, you get 40 ohm. So next, determine V22. V22 refer to the ratio between V2 and I2. So what is the V2? V2 here, Kirchhoff voltage law equals to V2 equals to 30 I2 plus 40 I2, right? So divide by I2, you can get 70 ohm. So this is the test. First test, you need to open circuit at port number 2. Second test, open circuit at port number 1. After that, you got the ratio, or this ratio, in order to determine Z parameter. So you will get 4 answer. So not 4 answer, 4 value for Z parameter. We have 60 ohm, Z11, Z12, Z21, then Z22, right? Okay, so that is the Z parameter. So this is an example here. Basically, you will do this on exercise, on tutorial. Same thing here, the same concept you will apply. If you have like this, we have two J20 ohm, negative J4 ohm. Basically, you assume this as a impedance, right? Because this is impedance. So just make it the same thing. I open for port number 2, then second test I open at port number 1, find the ratio, then you can get the same answer. So the same concept will be applied, although they have the J value here, right? Right, for example here, we have another technique, although you don't have to set it as a sorry. All right. Another technique, in order to determine Z parameter, you need to do a loop equation. So this loop equation is applied for T parameter circuit. Why this we call as a T parameter because it's look like a T. Here we have one junction here and this we call as T circuit, right? For the T circuit, it's easy for you because this is one you can, without using two tests, I1 or I2 test, you can use loop equation in order to determine Z parameter. So how this equation will, you get from the Z parameter from the equation, if you do looping, so if you do here, minus V1 plus I1, 2 ohm plus minus negative 4 I1 minus I2 equals to 0. So you rearrange that, you can get V1 equals to 2 I1 minus J4 I1 plus I2. A second loop here, you do a second loop, negative V2 plus I2 J2 minus J4 I2 minus I1 here, right? So using this looping, you can get this loop equation. So you need to rearrange this equation to become only I1 here, V1, 2 minus J4 I1. So this is for I2, V2 equals to negative J4 I2, I1 minus J2 I2. So if you do this rearrangement, why you need to do this arrangement? You need to compare with the Z parameter equation. From here, you can see here 2 minus J4 equals to Z11. So straight away you can get, so this is 2 minus J4. Negative J4 equals to Z12. This one also negative J4. And then Z22 equals negative J2. So this is another way to determine Z parameter using loop equation. From this loop equation, you need to rearrange again and compare with the general formula for Z parameter, and then from there you determine Z11, Z12, Z21 and Z22. So that is another way to get the Z parameter. Okay, any question before we go to Y parameter?
So far okay, Doctor.
Okay, good. So for Y parameter, it's the same thing with Z parameter, but the difference is means the same analysis as we go through the Z parameter, but the Y parameter basically is inverse of Z parameter. We call Y is a admittance, right? So for admittance, you have a linear network, you need to represent this network with the admittance. So in this equation, basically I1 equals to Y11 V1 plus Y2 V2, I2 equals to Y21 V1 plus Y22 V2. Basically this is general equation for Y parameter. So if you put in the metric form, they will be like this: Y1 equals to Y11, Y12, Y21, Y22, V1, V2. So if you expand this metric, it will be same as this general equation. So if you apply a short circuit, okay, for Z parameter you open circuit test, for Y parameter you short circuit test. Short circuit test means you apply V2 equals to 0. So when you apply V2 equals to 0, you can get Y11 and then you can get Y21. Means that you apply V2 equals to 0, you can get Y11, Y21. So if you apply V1 equals to 0, means you short circuit at port number 1, you can get the ratio I1 over V2 for Y12, for Y22, the ratio is I2 over V2. So you need to determine all the Y parameter according to this equation ratio. So this is a name for all these parameter y11, y12, y21, y22. So basically it's the same thing here. If you apply v2 equals to 0, you can get the y11 and then y21. If you apply v1 equals to 0, you can get y12, y22, right? All right, so next, how to get all the parameter. We have two tests. First test, you short circuit at port number 2, means that V2 will be 0. You short circuit here, but I2 is still appear on your circuit, but only V2 we set 0. And then for admittance, basically you apply current source, right? Apply current source, not voltage source, right? So when it's much easy to do analysis because if you see here, your equation is start from current source I1 and I2. So when you apply V2 equals to 0, this is to determine Y11 and Y21, right? So next, you short circuit at V1, so it means that you apply short circuit at V1, then you get the parameter for Y21 and Y22. Because Y12 equals to I1 over V2, Y22 equals to I2 over V2 when V1 equals to 0, right? So this is equivalent circuit for Y parameter. We have equivalent circuit for Z parameter. You have equivalent circuit for Y parameter, right? So this is equivalent circuit for Y parameter. After you got all the parameter for Y, then you can put this is a Y11, Y12, current dependent source, V2, Y21, V1, current dependent source, and then we have admittance Y22, right? So the unit for admittance is mho, the inverse of ohm, right? Or Siemens. S, the unit for admittance. So this is equivalent circuit for Y parameter. If the circuit is reciprocal, you can represent the equivalent circuit much in simple form, like this pi equivalent circuit. This is called as a pi because it's like a pi circuit. So when you draw this pi circuit, basically what is the value inside the pi? So this is negative y12, y11 plus y12, here y22 plus y12. So this is a reciprocal equivalent circuit for admittance. So how they know this is reciprocal or not? You need to compare this value y12 equals to y21. If the same, so this you can represent the Y parameter into reciprocal equivalent circuit, right? So if symmetrical mean you need to compare Y11 and Y22. If the symmetric is same, so this we call as symmetrical network. So if we go to this example here, find Y parameter of the circuit shown below. This is a pi circuit because it's pi. So here they ask you to determine Y parameter. Right here, state here Y parameter, not Z, right? Previously is Z, now it's Y. It depends on the question whether they ask you Y, Z, H, or transmission parameter. So Y parameter. So what next you need to do? You need to do two tests. Test number 1, short circuit. Port number 2, test 2, short circuit port number 1. Right. For example, here you short circuit port number 2 means that you set V2 equals to 0, and then determine the ratio of Y11 and Y21. Y11 equals to I1 over V1. Y21 equals to the ratio of I2 over V1. So from this ratio, basically you can get the Y parameter, right? So if we see the equation, the solution here, first when you set V2 equals to 0, you need to determine a relation between I1 and V1. So what is the relation between I1 here and V1? So from this circuit here, you need to do analysis here. So V1, where is your V1? V1 will be here, but V2 will be 0. I2 is still here, right? Because this is a complete circuit. So will we have I2? I2, if you you see here, the I2 will be go into the port number 2. So this is a fixed direction for I2. This is a fixed direction of I1. You cannot put I2 become like this. It's directly here go to the port number 2. Right. So this port direction is must be like this. Go inside for port number 2. Same thing here. The polarity is plus minus for V1. Right. So next, determine V1. So V1 is and go to 20 ohm direction. So basically, it will be you need to use current divider rules in order to determine IA. Right. So from here, IA equals to 5 over 25 plus 5 become 25 I1. So this is IA. V1 equals to 20 times IA here to get V1. So you replace IA with the equation. So you can get a ratio between I1 and V1. From there, you can get Y11 equals to 1 over 4 S unit for Siemens, right? Next, you need to determine Y21. Y21 is the ratio between I2 over V1. So this is your I2, so this is your V1. So how to get the ratio between I1, I2 and V1, right? So from here, you can see that V1 equals to 5 I2. Why? Because this is direction has been put assigned for two-port network. I2 go into this direction, right? So basically V1, because this is parallel, so voltage across 20 ohm will be same as voltage across 5 ohm. So V1 will be same as minus 5 I2. This is direction is different because this is assigned for the two-port network. So basically positive is for V1 is from here. Positive and negative mean current go to this direction. So that's why they have negative sign. So V1 equals to negative 5 I2. So if you got the ratio I2 over V1, you can get Y21 admittance value. Right? So negative 1 over 5 Siemens for Y21. Next, second test, you set V2 equals to 0. That this is short circuit for V2. What you need to do next, you determine the ratio for Y22 equals to I2 over 2, and then Y12 equals to the ratio between I1 and V1. For this first ratio, I2, V2, so it's the same thing here, the current is go to I2. This direction is the same for I1. Go inside the port number 1. So this direction you like just like this, but I want Ix, you can determine as like this, right? So V2 equals to Ix 15 ohm, V equals to IR, right? So from here, Ix is not this I2 because the I2 will be separate to these 2 points here. So using current divider rules, Ix equals to 5 over 5 plus 15. So let me check. 20. All right, so mistake here. Suppose this is not 15 ohm. So this one is not 25, right? So this is, what is the value for here?
15.
20.
50.
15.5. 20 kat
Oh,
sini.
yeah.
Alright,
Yes.
right. So this is 20. So Y22 equals to I2 over V2. So if you put here, go inside here, 15, so 15 Saya tak ada pen kat sini. Berapa ini jadi? 5
5/10.
5/20 kan. So
Yes.
5/75 bahagi 20. 20. So 5/5/20.
1/4.
Dapat berapa Y itu tu?
1/4.
1/4.
Sekejap. No. Sorry.
Saya tak kira. Okay, 5/20 here, right?
Yes.
4 here, 15/4/15. Betul lah, jawapan dia betul kan?
Depan betul.
Sini je salah kan?
Yes.
Sini sepatutnya 20, right? Jawapan dia betul. Okay, good. Right, so here you need to make a 20 here, 25, but the answer is correct, right? 4/15 S. So next, determine the relation between I1 over V2. So I1 over V2, you need to go back to this circuit. This circuit basically when you set V1 equals to 0, you only have the resistance, it will be short circuit. If you go to this original circuit, do the short circuit here, it bypass 20 ohm, right? If you do short circuit here, it bypass 15 ohm. So then you can see here, when you do short circuit here, it bypass 15 ohm here. So dia bypass kat sini lah sebab V2 dah short V1, so dia bypass 20 ohm because this one is a short circuit. Next, determine the ratio of I1 V2. So where is your I1? So this is I1, need to the ratio V2. So here you can got V2 equals to 15 Ix. So where is your Ix here? Times 15 here. Not 15. The net ratio between I1 and V1. V2 equals to, because this is parallel, V2 and I1 is 5 I1 will be same. 5 ohm times I1 will be your V2, right? So V2 negative 5 I1, because this direction is basically is inverse for V2. V2 kalau kita tengok kat sini dia positif, negatif. The current will, but for I1, if current will go here, will be positive and negative. So basically, inverse of current I1 times 5. Then get the ratio I1 over V2 will be 1/5S. After you got all this parameter put into the metric form, we have 1/4, -1/5, -1/5, 4/15. The unit will be Siemens. Okay. All right. Any question? Okay. Right. So same thing here. This example we put into tutorial, right, for tomorrow. Right, for H parameter, some of we call H hybrid or H parameter. Some two-port network cannot be expressed in terms of Z and Y parameter, but can be expressed in terms of H parameter. Parameter can be determined by calculation or measurement, right? Example here, we can apply linear network. We have V1, I1, I2, V2. So the hybrid parameter means that it's combined between two tests. We have open circuit test for port number 2, and then we have a short circuit test for port number 1, right? So all right, so basically not that So basically this parameter we only apply on this port. So we will go through here first. So V1 equals to H11 I1, H12 V2, I2 equals to H21 I1, H22. So mean it's a hybrid between a voltage and current here, right? So voltage and current is make V1 then I2. After that, you come out with this metric form. So this is metric form that represents H parameter, H11, H12, H21, H22. But how to determine all these parameters? Let me see what is the test that you need to do in order to get all these parameters H11, H21, H12, H22, right? So this is the equivalent circuit that represents H parameter. We have H11 here, H11 V1. So if you do looping here, V1 plus H11 I1 plus H12. Another point here we have I2 equals to current here, H21 I1, V2 over H22, you got current here. Right. So this is the hybrid parameter equivalent circuit. If this reciprocal, which means that H11, H12 equals to negative H21, this is we call H parameter, reciprocal in H parameter. If you do the test H12 equals to negative H21, it will be reciprocal. If for symmetrical, you do this H11 times H22 minus H12 H21, you will get 1. So if you do this, means that this H parameter is symmetrical, right? So there is no equivalent circuit for H parameter network, but basically you can represent the model for parameter according to this circuit equivalent circuit, right? Alright. So next, we need to find the parameter. So the parameter first you need to determine H11, H21. From here you can see this equation H1, H21. You can determine it by setting V2 equals to 0, right? So first, in order to determine these two parameters, H11, H21, you need to set V2 equals to 0. So it means that you short circuit port number 2. When you do this test, you short circuit port number 2. It means that you set V2 equals to 0. You can get H11 and H21. So H11 equals to V1 over I1. H21 equals to I2 over I1. So the unit for H11, because this is voltage over current, is a ohms, same as a Z. For H21, I2 over I1, this is ratio current over current. So there is no unit for H21. So next, hybrid parameter, because you mix voltage and current, right? Next, in order to determine H12 and H22, you open circuit at port number 1. So when you open circuit, you set I1 equals to 0. From this equation, when you set I1 equals to 0, you can get H12 equals to V1 over V2. So this is a ratio of voltage 1 over voltage 2. Because this is a ratio of voltage, there is no unit for H12. For H22 equals to I2 over V2. So I2 over V2. So because I1 equals to 0, right? You set I1 equals to 0. So I2 over V2 you can get H22. The unit will be Siemens because it's inverse of impedance, right? So the unit will be Siemens. All right, so for this example here, find the H parameter, right? So you know this is equation for H parameter. So you give this circuit, you need to determine H parameter. First test, you set V2 equals to 0. So this you set V2 equals to 0, means that you short circuit this point and then apply current source here. So from there, you need to determine when you set V2 equals to 0, means that you can determine H11 based on V1 over I1. So from here, you need to determine the ratio between V1 and I1, right? So how to get V1 and I1? So basically, you can use Ohm's law, because this is a short circuit, 3 and 6 in parallel. You can get, and then get the total resistance for this circuit after this parallel plus 2 ohm. So you can get V1 equals to I1 total resistance here. So it will give you 4I1. So H11 equals to V over I1 for ohm. So this one is straightforward. Ohm's law to get the H11. The ratio of V1 over I1 will be H11 equals to 4 ohm. Next, you need to determine H21. How to determine H21 is based on ratio I2 over 1. So here, if you set V2 equals to 0, so you can get H21 equals to I2 over I1. So you need to determine ratio I2 over I1. Okay, this is I2. I2, the direction of I2 will be like this. Because this is the, you cannot change the direction of two-port network for I2, I1, V1, and V2, right? So the direction of I2 will be like this. So the I1 will be go inside the current, inside the circuit, right? So I2 using current divider rules equals to 6 over 6 plus 3 times I1, because I1 is current that go through this branch, right? So we know that this is different direction of current I1 supposed to go like this, but this direction is go inside the port. So that's why we have negative here. So negative I2 will be 6 over 6 plus 3 I1. Then you get 2 over 3 I1. Get the ratio I1 over I2 over I1, and get negative 2 over 3. So there is no unit for, so the current H21, right? Because this is current over current, there is no unit. So next, you need to set I1 equals to 0, open port at port number 1. So apply voltage port number 2, because this is hybrid. So you're hybrid between Z and Y testing, right? So next, what you can get by setting I1 equals to 0, setting I1 equals to 0, you can get the H12 relation between V1 and V2. Although you open circuit at port number 1, or you set only I1 equals to 0, but V1 is still there. So V1, because this is current is 0, so there is no voltage drop at 2 ohm. V1 refer to the voltage drop at 6 ohm only. So V1 equals to get this voltage across here, you can use voltage divider rules from 6 plus 3 times V2, you can get V1, 6 over 6 plus 3 times V2. So the ratio between V1 over V2, you can get 2 over 3. So basically, the two-port network, you need to find the ratio, right? So how to, the ratio is according to the general equation for the parameter. For example, here, H parameter, you need to determine ratio V1 over V2, which is 2 over 3. Next, to determine ratio between I2 over 2. So why I2 over 2? If you look to this general equation, when you set I1 equals to 0, when I1 equals to 0 here, you can get H22 equals to I2 over V2, right? According to this equation. So H22 equals to I2 over V2. So this is your V2, this is your I2. Using Ohm's law, this simple method to determine current voltage, right? V2 equals to total resistance here, because there is no current flow here, 3 plus 6 ohm times I2. So 9 I2, V2 equals to 9 I2. The ratio I2 over 9 V2 will be 1 over 9. So this unit for H22 is as Siemens. So that is for hybrid parameter. Any question?
So far, good.
All right, good. The last parameter we call as a ABCD parameter or T parameter, transmission parameter, right? So the T parameter or ABCD parameter is another set of parameter related to variable at the input port to those at the output port. So the T parameter called as a transmission because these parameters are useful in the analysis of transmission line because they express sending and variable V1 and 1 in terms of receiving and variable V2 negative I2. So let we see what is the transmission parameter. So this is the transmission parameter. They call as A11 or no, it's not called A11. Basically, A at this 1 1 position, B is 1 2 position, C at 2 1 position, D is 2 2 position. So basically, we represent this as a V1 equals to A V2 minus B I2, I1 equals to CV2 minus DI2. So this is general equation that represent T parameter or ABCD parameter, right? Your task is to determine what is the A, B, C, and D here. So in order to determine ABCD parameter, so A, B is dimensional, means there is no unit for A and D. B is the unit is ohm, B here ohm, and as C is Siemens. Right. So this is unit for ABCD parameter. The value can be evaluated by setting I2 equals to 0, input port open circuit at port number 2, and V2 equals to 0 mean output port short circuit at port number 2. So we have only two tests at port 2 only. Set I2 equals to 0 by open circuit and set V2 equals to 0 mean by short circuit. There, basically, if you have, when you set I2 equals to 0, you can get A equals to V1 over V2, ratio between V1 and V2, you can get A value, C value, I over V2, I1 over V2. When you short circuit at port number 2, you can get B value, which is V1 over I2, and D value, I ratio between I1 over I2. Right, so this is two tests, set I2 equals to 0 and set V2 equals to 0. In terms of transmission parameter, in network is reciprocal if. So this is how you determine the reciprocal or not. You this value A and D, you times A and D minus B and C must be 1. If not equals to 1, it's not reciprocal. But if equals to 1 means it is reciprocal. All right, for example here, determine ABCD parameter or T parameter of the circuit shown below. We have this resistance component here. So you can see here for the Z parameter, not for two-port network, V1, you need to fix. This is a V1 polarity plus minus, and the current will go to the input port. For V2, this is the polarity for V2 plus minus, then the input current will be go to the output port here, I2. So this direction, the polarity for V1, V2 is a fix. So you cannot change this direction when you do the analysis. All right, so first, from this circuit, you set I2 equals to 0, means that open circuit. So you open circuit this port, so there is no current that this go through I2, so your circuit only have 2 ohm and 10 ohm only. But the voltage still V2 is appear in the circuit because this V2 will be refer to the 10 ohms punya voltage drop, right? So that's why we have V2 across 10 ohm here. So when you do this analysis, to get the C parameter is referred to I1, the ratio between I1 and V2. So how to get this I1 and V2? You see that this is V2 equals to 10 I1. So I1 over V2 will be 0. Siemens. So you need to determine this ratio, I1 over V2, in order to get C value. Next, you need to determine the ratio between V1 and V2. So this is your V1, this is your V2, right? So using KVL loop here, Kirchhoff voltage law, negative V1 plus 2I1 plus V2 equals to 0. So you see that this I1 over V2 over 10. So you replace I1 in V2 equation. So you can get V1 and V2 variable in this equation. You need to make sure you have V1 and V2 this equation because you need to determine the ratio between V1 over V2. So at the end here, you can see V1 over V2 equals to 6 over 5 or 1.2. There is no unit because this is a voltage ratio. So this is 1.2. Right. So this is value for A. So this is another way to determine A. But basically, if you do a different analysis, it's okay. But make sure at the end you need to determine this ratio V1 over V2. Right. Whatever you do is okay, but make sure you can get this. At the end you can get this the ratio between V1 over V2 that represent A. Next, you need to set V2 equals to 0. So if you go back to the original circuit here, when you set V2 equals to 0, means that you short circuit here, right? You do the short circuit at bit number V2 here. So next, what happened to the circuit? When you short circuit here, right? So the I2 is still same direction. Here, I1 direction here, V1. Only V2 will be 0, right? So when you set V2 equals to 0, you can determine D and B. So D is the ratio between I1 and I2. So here, if you can see I1 and I2, you can relate using current divider rules. I2 here, because it's this direction go inside the port. So I1 go to this side. So that's why I2 is negative 10 here over 14. I1 using current divider rules, and then from there you can get the ratio I1 over I2. So the ratio here is negative. So if you go back to the first equation here, here I1, when you set V2 equals to 0, I1 over I2 must be negative D, right? So that's why you can see here, although it's negative I1 over I2, it will be 1.4. So this is a D value. For V1, next, B, the ratio is between negative V1 over I2. So the V1 in term of I2. So here is your V1. So V1 equals to, using loop equation, negative V1 plus 2I1 plus 10 I1 plus I2 here. Right. Then you rearrange the equation, I1 and I2. I2 replace with this I1 term. I1 here, because you want to ratio V1 and I2, so you replace I1 with the I2 punya equation. So 12, 14 over 10 I2. So this one I1 equals to 14 over 10 negative plus 10 I2. So you do this, complete this additional, you can get the ratio between V1 over I2, negative V1 over I2. At the end, you can get 6.8 ohm. So this is the B value that you get here is the B value. So at the end, you need to put into the metric form. So this is A value, B value, C value, and D value, right? So there means the unit here. So basically this is ohms, Siemens. There is no unit for these two, basically, right? Let me check. Yes, C is Siemens. So this is A, B, C, and D. So this is S, and B here is a ohm, right? So this is a T parameter. So that's it. Any question?
Okay, doktor.
All right, good. So basically,
Confusing lah.
apa dia?
A bit confusing.
Confused
Tapi okay lah. Dia boleh tengok balik.
Alright, good. Ada kawan you dah record kan? You tengok balik. Cuma dia ada 4 parameter yang mana you kena tengok soalan lah. Soalan tu nak parameter apa. Setiap parameter tu dia ada equation dia sendiri. So if you go back to the first slide here. So this is basically we have all this equation that represent parameter. We have Z parameter, dia ada equation dia sendiri. They have admittance parameter, they have equation dia sendiri, hybrid parameter, transmission parameter, right? So basically, what you need to do kalau soalan tu dia bagi circuit, from the circuit, dia tengok soalan tu dia nak apa? Contohnya dia nak Z parameter, so you kena refer to the Z parameter punya equation. So from the Z parameter, basically you need to determine all these parameters Z11, Z12, Z21, Z22, right? For example. So how to determine all these parameters? You need to perform 2 tests. For Z parameter, untuk dapatkan all these value, you need to perform 2 tests. Test pertama, kalau daripada equation ni pun kita boleh tengok lah macam mana kita nak testkan dia. Set I2 equal to 0 by open circuit at port number 2. Second test, short circuit, set I1 equals to 0 means open circuit at port number 1, right? In order to get another 2 parameter. After you done these 2 tests, basically you can get all Z11, Z12, Z21 and Z22 punya parameter. So that is for Z. If the question asks you for admittance parameter, you need to refer to this general equation. From this general equation pun you kena tahu kan. So kalau macam ni kita ada V1, V2, V1, V2. So need determine Y11 means you need to set V2 equals to 0. So when you set V2 equals to 0 means that you you short circuit. So for admittance, basically you short circuit dia punya circuit. Short circuit at port number 2, you can get Y11 and Y21, and then next you short circuit at port number 1. So it means that you put V1 equals to 0 to get another 2 parameter Y12, Y22. So this is for admittance parameter. So but basically the ratio is depend on the circuit itself. Kadang-kadang circuit tu dibagi dalam T, pi punya, dia ada beberapa configuration lah. So you need to manipulate the ratio. What is the ratio? So if the ratio between I1 and V1, so you need to manipulate the analysis in order to get the correct ratio, right? So that is a little bit confusing because you need to play around with the analysis. What is the best analysis in order to represent the ratio between, for example, I1 over V2, for example, right? So that is the more complicated part lah. But the first part, you need to determine this general equation. From this general equation, you know that you need to do 2 tests in order to determine all these parameters. For hybrid, for example, this is general equation, this is a fixed equation, right? So you need to do the 2 tests here. First, we set V2 equals to 0 by short circuit at port number 2. So you can get the rest here is the ratio between V1, I1, I2, I1 to get this H11, H21 value, and then set I1 equals to 0 by open circuit at port number 1, right? For A, B, C, D, same thing here. You have V2, I2 means that both of tests will be at the output port. First test you set V2 equals to 0. By setting V2 equals to 0 means that you remove V2 in this equation. The rest is the ratio between V1, I1, I2, I1 and I2. Next, you set I2 equals to 0 by open circuit at port number 2, can get all these parameter according to the equation here lah, ratio between V1, V2, I1, V2 for example. So that is the two-port network. You need to do two tests in order you need to determine all the parameter based on the equation how to determine the parameter there. You need to perform two tests, whether it's open or short circuit test. The rest is up to you how to analysis the circuit, right? So that is more challenging part to get the ratio, to get the analysis done. All right, but I think maybe you will be more confident to do this when they have a tutorial session, means that you do the exercise. After that, maybe you may get some idea how to solve this problem. Okay. So, any question before we end of chapter? See.
Tak ada, Doktor.
Uh-huh.
Tak ada.
Tak ada.
Okey.
Okay. Yang lain, okay?
Okay, Doktor.
Alright, good. So, session ni nanti share dalam grup kita, okay? So, kalau tak ada soalan, maybe kita boleh bersurai. Esok saya bagi tutorial and then kita ada 1 week lagi at the end of chapter 6, basically dalam tak sampai 10 slide lagi. So, kita jumpa lagi lah next week.
Alright, Doktor.
Alright.